Good morning, everyone. Thank you for joining this webinar. My name is Fred Senecal. I'm the head of R&D here at Learning Machines. I'll be your host for the webinar. So this webinar and the webinar series is hosted by Learning Machines. We're a consulting firm. We specialize in machine learning, big data, and cloud services. And if you want to learn a little bit more about Learning Machines and what we do, you're most welcome to join our website at www.learningmachines.co.za. So today's webinar is part of a 5-part series. We investigate the applications of machine learning and artificial intelligence, mostly to unstructured data, so things like text, voice, and image. And we've prepared quite a number of interesting webinar topics for you. So the next one will be on speech and voice processing in 2 weeks' time. And if you're interested in joining any of our webinars, you're most welcome to register for them on the website. I also just like to mention that we will send a link to the different videos. We're recording the webinars, and we'll send you the link via email. Right. So today's webinar will be on machine language translation. And we'll also have a look at text search for enterprises. And we're specifically going to have a look at 2 of the services provided by AWS, namely Amazon Translate and Amazon Kendra. And I think after the presentation, we'll have a Q&A session. So you're welcome to have some questions and ask them to us. But if during the course of this presentation, you have some burning questions, you're also welcome to use the chat facility. There's a number of my colleagues that's also in this call, and they'll do their best to try and answer your questions. So let's start off maybe by talking a little bit about language. Now, if you think about it, our ability to process language is very native. In fact, there's quite a bit of research to show that our ability to learn a language is part of our DNA. And so we are born with the ability to process language, to learn new languages. And from a very young age, we start to learn language from our parents and from our caregivers. And so it really forms the basis of how we learn about the world and the way in which we express our thoughts, how we express our feelings, how we express our desires. And if you think about it, it also then forms the basis of our society and our culture and our scientific understanding of the world. Now, importantly, many people associate with a native language. It's the language in which people should be educated. It aids them in getting to grips with the world. And it also gives people a sense of belonging. They feel comfortable in a specific language. And it's perhaps best summarized by this quote from Nelson Mandela, where he said, "If you talk to a man in a language he understands, it goes to his head. And if you talk to him in his own language, it goes to his heart." Now, of course, it would be quite nice if we could speak to anyone on this planet in their own language. But there's a few problems of that. The first one being that there's quite a number of different languages being spoken around the world. At the moment, there's more than 7,000 different languages that we know of. And there's obviously a few that we are not aware of, people in very, very remote villages, which we still haven't discovered the languages they speak. Also, there's different ways in which language is represented. So there's different language systems, there's different scripts. And these different languages and scripts make it quite difficult for people to understand those languages. If you think about, if you're used to the Western alphabet, the Latin alphabet, some of the symbols that people use to express their words would probably be quite incomprehensible. And so if we want to speak to the hearts and minds of people from around the world, it then becomes necessary that we translate the content into their native languages. Now, although it's probably quite infeasible to translate it into all the languages of the world, it is probably quite feasible to translate your content into a select few. And in fact, the stats show that about 23 languages are necessary to cover half of the people in the world. Most larger corporations typically translate their content into 40 languages or so. Now, what does this mean, and why is this important? Well, if you are selling content on a website and you're involved in e-commerce, which is very topical now that we are under the COVID pandemic, the stats show that 55% of consumers will only buy on a website that is in their own language. And this is quite a interesting statistic. It means that if you were to provide content or offer products in a native language of someone, you could very easily double your reach and your return. Now, if you imagine, for instance, I'm sure all of you have a smartphone. Imagine if you were to go onto an app store, and that app store would give you content in a language which is incomprehensible. So for me, if I were to have content that is in Mandarin or in Russian, I wouldn't know what this app is all about. And so I would most likely not download an app. And if someone has gone through the trouble to actually translate their content into my native language, or in a language that I understand at least, I would much more likely to download their content. So the bottom line is that consumers expect content to be in their native language. And if you have a company, those consumers will also then expect you to be able to interact with them in their native language. Now, obviously, that means that your content has to be translated, and you could probably try and do a manual translation. You could probably, if you have very little content, you could ask a friend to do it. And unfortunately, you would get something like in this little graphic here, and it's really a bit of a slippery slope. And so most large corporations would hire a language professional to do the translation. Now, unfortunately, hiring a professional suffers from a number of drawbacks. First of all, it's manually intensive. And so for each language that you need to translate content into, you would need a translator for that specific language. It also takes quite a bit of time. So a typical language translator can translate up to 2,000 words per day. So if you have a document, say, of 10,000 words, that would take at least 5 days then, or an entire week for the translation to be done. And it's also quite costly. So in South Africa, translation services run from about 90 cents to R1.50 per word. Or if you were in the US, a translation per word would cost anything from 10 to 15 cents in the dollar. And so you could quite easily get quite a bill for your translation needs. So let's have a look at business use cases where machine translation can be applied with great success. So the first one is for content that is time sensitive. So if you imagine something like a news feed, which is perhaps there's live captioning, and you want to be able to translate that caption to a specific audience, that would be time sensitive content. There wouldn't be any time for a human translator to do the translation. Suppose you have something like your customer service and they need to interact with someone which perhaps speaks in a different language. You would require on-the-fly translation of what they're saying. And so in many cases, if you have time-sensitive content, it's more important to actually understand what is being said, even though there might be some errors, than to delay the process. The next big use case is for content where there's quite a bit of volume. So if you think about what users do on the internet, if you think about things like social media or review or forums, there's a large body of content that gets generated. And you need to be able to understand what your customers and your clients are saying about you. Maybe you want to have feedback about what they think of your products, but it's written in a different language. Perhaps you want to extract sentiment from what they are saying. And so you need the ability then to process large volumes of data. And it's not so much, again, about the quality of the translation, but it is more to get a feeling or an idea of what people are saying about you. Of course, also, if you internally want to search things like a data repository, if you think about your own internal knowledge bases or so, and you've a large multinational corporation, then obviously there'll be data that's in different languages, and you would want to search that content depending on, or translate the content depending on who is requesting the content. Now, in some cases, obviously, your content should be of the highest quality. If you think about things like your documentation for your products or your internet website, user interfaces or legal documents and so forth, those documents should reflect the highest quality. And so you can set up a workflow where you start by translating it using a machine. And then once it's translated, for the human translators then to do final changes to the document and then improve the quality if there were a few errors. In which case, the cost of that would be much less than if you were to pay a human translator from the onset. Now, the service that's provided by Amazon or AWS is called Amazon Translate. And it's a fully managed and continuously trained machine translation service. Now, the benefits of Amazon Translate is, first of all, that it's accurate. Secondly, it's really easy to use, and it is quite affordable. And I'll explain each one of these different advantages in a little bit more detail. So let's first talk a little bit about accuracy. Now, the state of the art at the moment in machine translation is what is called neural machine translation. So in the olden days, people used to do something called statistical machine translation. And statistical machine translation relied on translating short phrases of text based on statistical methods. And these short phrases would usually look at only a few words, and based on those few words, would then determine what would be sort of the correct translation for the next word in the sequence. Now, since about 2014, the work on neural machine translation methods started, and there's been vast improvements in the quality of the translations. Now, these neural machine translation methods work is that you take an input sequence, which is then encoded into some form of a mathematical representation, and that mathematical representation is then decoded again to get you an output sentence in a different language. Now, the translation from a text-based input to a vector representation of that text is usually done through something called a recurrent neural network. In many cases, they have what is called a bidirectional recurrent network. And basically, it creates a semantic representation of language which is independent of the language. And so it's really a bunch of numbers or a vector of numbers that represents the language. For longer sentences, however, these methods in isolation are still lacking in some regard. And over the last couple of years, there's been attention mechanisms that's been built into it. So if you have a large sentence, these attention mechanisms would focus on specific words within the sentence. And then based on those words would then allow you to decode the message in a much better way. And so Amazon Translate is built around these neural machine translation models, and it's continually updated. So without you having to do anything, these neural machine translation methods are being upgraded in the background, and you get the benefit of the state-of-the-art technologies as they are being developed. In terms of ease of use, it's really quite easy. It's almost, embarrassingly easy. So Amazon gives you SDKs for various computer languages, whether you use Python or JavaScript or anything else. You have the APIs that can be accessed, and it's quite fast. So there's some guarantees on how quickly these translation services would work. You also then have different processing modes. So the example that I'm showing here, which is a bit of Python code, that center portion there, you would really just pass it in a bit of text, the source language and the target language, and in real time it would then translate the text for you. But you can also set up batch processing. So if you have a large corpus of documents that you would like to translate, you could upload those documents into something like an Amazon S3 bucket, and you would start a batch job, and it would then translate all the documents on your behalf. So then the other benefit of Amazon Translate is obviously the cost associated with the translation. So the cost at the moment for Amazon Translate is for 1 million characters would work out to about $15 US. Now, if you were to use a human to do the translation on a budget of $15, that would give you about 150 words or so. And so you would be quite limited in what you could achieve on your budget. Now, if you have a look here in the table, something like an average email message might cost something like 4 cents in the dollar, or a typical news article might cost something like 10 cents in the dollar or so. And so it's really a very, very affordable option. And Amazon also gives you a free tier where you get to translate up to 2 million characters per month for free for the first 12 months. Now, in addition, if you want to translate your content, you also sometimes need to be able to specify custom terminology. So if you have the language models that's already trained, in some instances, they might not be able to understand your products or your specific terminology that you use. So if you think about things like brand names or company names or product names, all of those things will need to be translated in a custom way. And so Amazon Translate allows you then the ability to specify these custom terminologies. And I'll show you an example of that a little bit later. It also gives you the ability to automatically detect the language in which your text was provided. So if you think about the use case, like someone writing something in a language that you do not recognize, you can use Amazon Translate to automatically detect the language and then translate it into your target language. And then just a note here, the information is obviously also encrypted. So both in rest and in transit. So if it's in rest in something like a S3 bucket, there would be server-side encryption. And in transit, it would use something like TLS with Amazon certificates to make sure that your information is kept secure. So let's take an example of language translation. So let's have this language English sentence here, which says Learning Machines is a Johannesburg-based consulting firm specializing in big data, machine learning, and cloud services. And let's see if we can translate that into different languages. Now, I'm sure most of you in the audience come from South Africa. And unfortunately, I'll have to pick a different language here. And one of the languages that Amazon Translate provides is Afrikaans. And let's see what the translation is that it gives to this sentence in Afrikaans. And the translation comes out as Learning Machines is 'n Johannesburg gebaseerde raadgewende firma wat spesialiseer in groot data, masjienleer en wolkdienste. Now, being a native Afrikaans speaker myself, I would have never have guessed that something like cloud services would be translated as wolkdienste. But I guess that is probably a very, very good translation. I'm sure a couple of you in the audience are chuckling here. But I think if you have a look at the translation there, it's quite a good translation. And so we might be able then to translate it into various other languages. So yeah, I've got Swedish, I've got Russian, I've got Chinese. And obviously something like Russian and Chinese, I might not be able to understand those characters there. But in Swedish, if I have a look at the words, and it's being a language which originated in the same area as where English originated, I can sort of see that some of the words in that sentence are quite similar to the words that I would expect. Now, in terms of language support at the moment, there's 55 different languages which is supported. Unfortunately, not many African languages. At the moment, there's support for Swahili. And I'm sure, some of the other languages that are spoken here locally in South Africa, like Zulu and Xhosa and Sesotho, which is currently being provided by some of the other cloud service providers, will be incorporated into Amazon Translate quite soon. Right, so let's do a quick live demo, and then we'll move over to Amazon Kendra. All right, so let's take a couple of examples here of neural machine translation. And here I've got the song from Pavarotti, Nessun Dorma. And I'm going to leave the source language here as auto, which means that Amazon Translate will be able to detect the language, and I'm going to ask for a translation. And the translation comes out as, no sleep, no sleep. You, a princess in your cold room, watch the stars trembling with love and hope. And it's sort of, you can see that the language was detected as Italian. And I guess Pavarotti is here singing about the princess in a lonely castle. And if I think about Mario Brothers, it's sort of like the Italians, they love their princesses and their lonely castles. Let's take a different example here. A song from Edith Piaf. Let's translate that. No, I don't regret anything, which is correctly translated, detected as a French sequence. This is quite a favorite of people. The quick brown fox jumps over the lazy dog. And let's translate that, say, into Afrikaans, so that some of the audience members might understand what it says. If we do a translation here, we see, die vinnige breinjakkals spring oor die lui hond, which I think is probably quite accurate. Now let's take an interesting example here. So we're taking this example of learning machines. Is a Johannesburg-based consulting firm specializing in big data, machine learning, and cloud services. And we ask Amazon Translate to translate that. And out comes the following sentence. Leermachine is 'n Johannesburg-gebaseerde raadgewende firma. And obviously this word leermachine comes from the word learning machines. And so you can see the need for custom terminology, where you would like to take specific names and translate them into a specific language based on a set of words that you've specified. So I'm going to put it on the tick box here to say use custom terminology. And if I translate it now, I can see that learning machines, which is our company name, stays learning machines. Let's take a different example here. And suppose we now have an operator which is chatting and giving customer support to one of the clients. And let's suppose that this client wants to say something in Afrikaans. So let's go and let's type something and we say, Goeiedag. And we sent the message Goeiedag. Now, on the operator side, which is perhaps configured to speak in English, the operator might see something like good day. And he might say something like, hi, how may I assist you? And on the other side, what the client might see is something like, hi, hoe kan ek jou help? And let's say something like, daar is 'n probleem met my bankrekening, or there's a problem with my bank account. And our operator on this side might see this, might type a response like, what is the problem? And on this side, the client might see something like, wat is die probleem? And let's say our client says something like, daar's te min geld and there's too little money in it. And so two people from two different languages might then be able to communicate with each other through something like a machine translation service. All right, let's move on then to Amazon Kendra. All right. Now, if we talk about Amazon Kendra, and we talk about searching large bodies of information on a corporate website or so, the question comes to mind, what do your employees need to be able to do their job? What types of information do they need, and how do they get the information? And if you think about most corporates and enterprises, there's really two things that plague this type of search. First of all, there's lots of different data sources, and these data sources are typically in silos. There's maybe databases or data warehouses, different kinds of company reports or FAQs. And it's quite complex then to integrate all of these different data sources into a single place where people might be able to access them. It's also difficult to set up the connections to bind these different data sources and to maintain the infrastructure to give people access to the information. Secondly, it's quite difficult for companies to ensure accurate results. So certainly many of the corporate websites that I've seen would spit out lots of different documents associated with a search, but they often fall short. And so we need better ways of handling the complexity and the accuracy of search when we have these enterprise search engines. Now, some studies by McKinsey say that employees spend up to 20% of their time looking for information every day. I guess in the information age, and we have knowledge workers, this is certainly quite true. If I take myself as an example, I spend most of my day looking for information and trying to find the right information. Now, the scary thing is that a lot of the time, 44% of the time, in fact, people can't actually find the information to do their job. And so there's quite a bit of productivity that is lost. Now, Amazon has seen this need to reduce the complexity and to improve accuracy for enterprise searches, and it's introduced Amazon Kendra to solve this problem. Now, Amazon Kendra is a highly accurate and easy to use enterprise search service, and it's powered by machine learning. It's only been introduced for general availability in May 2020, so it's only been around for the last month and a half or so. It gives you the ability to search unstructured text sources and to do that using natural language queries, which for most users would be very, very easy to use. So to address issues of complexity, Amazon said that they need to build native connectors to various data sources. And I'll talk about the native connectors just now. They also provide you with a simple API with which you can then query these different data sources. And they focused quite a bit on the accuracy. So they give you the ability to ask questions in natural language. The core of all of this is in the natural language understanding and machine learning models. They've built in various types of domain expertise. And they are, of course, continually improving the machine learning models that is powering all of this. So first, in terms of data sources, at the moment, there's support for 6 different data sources. You can upload your information into something like an Amazon S3 bucket, which is really just a place where you store your different files. You have access to Amazon RDS, so the relational database service, which gives you access to data which is stored in Aurora, MySQL, and Postgres. And you also can store your data in things like Microsoft OneDrive or SharePoint. There's also integrations for Salesforce and ServiceNow. And since it's quite a recently launched language, not all of the planned connectors are in place. So coming in 2020 are a few others, including support for file systems, Dropbox, Google Drive, Jira, Confluence, Zendesk, and Zendesk, and quite a few others. Now, within these different data sources, you would store different types of documents. So the unstructured types of data sources that you might store in these repositories include plain text documents, HTML, PowerPoint, Word, and PDF documents. But you also can upload structured data sources, for instance, your frequently asked questions. And in addition, you can associate metadata with each one of your documents. So for instance, what is the author of a document, or which department created the document, or when was it created, or how many views that document has received. Now, the steps for creating a setup is quite easy. You would start by creating what is called an index. The index is basically the central repository for storing the data and giving you access to the different machine learning models. And so you would start by setting up an index. Once you've set up an index, you would then add your data sources, so the different data sources that I've just mentioned, and you would then execute a syncing operation. And the syncing operation can either be on an ad hoc basis, or you can specify that the syncs happen at after regular periods. So say once a day or once a week. And what that does is then to pull the different data sources into your index and then update the index with the relevant information. In addition, you can add your frequently asked questions into the index. And once all of that is ready, you would then test your index and you would deploy it. And the way of deploying it would be to access it via your APIs, so your mobile or web applications can access it, and then query your index to give your users the information they require. Now, this index is based around some of the newest state-of-the-art language processing and machine learning models. And it gives you three main capabilities. The first one being the ability to read documents. So basically to gain some understanding of what is meant by the content within a document. And based on that, it then generates the ability for you to give answers to commonly asked questions. Secondly, there's FAQ matching. So you can specify certain frequently asked questions, and then it will look up the answers to those questions within the FAQs. And then finally, like a normal search engine, those documents are also then indexed, and based on a search query, they would be ranked. Now, importantly, these machine learning models are continuously updated. So as new technologies become available, these machine learning models are updated and are continuously trained. Also interesting is that based on your specific company and how users are actually clicking on results and giving feedback on the relevance of results, your results can also be adjusted over time. So the search queries over time might give different results based on user behaviors. Now, to start off with, there's a number of domains on which the machine learning models have been trained. So if you think about things like IT or financial services or health or energy, some of the basic sectors have been trained on. So that Amazon Kendra can make sense of the terminology that's used within those domains. And there's also plans then to extend to different other sectors and domains in the near future. Now let's take a look at the different types of questions that you can ask of Amazon Kendra. The first one would be what is called a factoid question. And so it's really a type of question where you would expect a specific answer. So it's typically a question to answer such as who did something, where was something done, when was something done, and so forth. So an example might be, who is the CEO of SpaceX? Or what is the height of the Eiffel Tower? Or when was a specific person born? If that type of information is contained within the ingested documents. Second type of question is what is called descriptive question. So these are questions where the answer is slightly more complex. So an example might be, what is the effect of the COVID-19 pandemic on the South African economy? And so you wouldn't expect a very specific answer. It's more something where you would have maybe a paragraph describing the answer to the question, and you would have to build some insight into what has been asked. And then finally, Kendra also supports keyword searches. So these are questions where you're not quite sure what you want to ask. You just want to get a gist of the content. And so something like if you were to say just cloud services, and you're just looking for documents that is related to cloud services, you would use such a keyword search. Let's take a couple of examples here. So what I've done is I've preloaded Amazon Kendra with a number of Wikipedia articles, and I'll show you a live demo of that just now. But let's take an example here. Who founded SpaceX? It's something with quite a clear answer. And what Amazon Kendra then is able to do is to say, well, supported by the evidence of the documents within the index, the answer to that question would be Elon Musk. And it would then also highlight you the portion which is the foundation for the answer. So in this case, Elon Musk founded SpaceX, and then the rest of the sentence there. And so Amazon Kendra are quite confident that the answer is Elon Musk. A different type of query is something where we might want to query our FAQs. So in this case, if we ask something like who discovered Mars, and of course Mars is visible to the naked eye, but what I've done is I've set up a FAQ which says that Galileo Galilei was the first person to make a telescopic observation of Mars. And so it found that specific intent in our set of frequently asked questions, and then based on that can give us an answer. Something like a keyword search, if we're just interested in, say, life on Mars, we might ask a question or just specify keywords like Mars life, and based on that, it would then try and find the most relevant document within the index. So in this case, it found the Wikipedia article on Mars, and there's a reference there to which might be able to answer the question. Now, in terms of improving these different queries, Amazon Kendra also gives you the ability to filter based on specific metadata that's associated with your documents. So your user might have the ability to filter on things like a date or an author or a department. And Amazon Kendra also gives you the ability to tune the relevance of your results, which influences the ranking of the order in which the documents are presented to you. So you might specify that certain data is more important. So for instance, if there's a match in a document title or a specific author, it might then boost some results for you. You might also indicate that some attributes is more important than others. For instance, document freshness, which is a date attribute. And so recently published documents might be boosted in your search results. Or something like a view count. So how many people have looked at a document before, and if you set up the relevant relevance tuning, you might then be able to get documents that are viewed more often to rank higher in your search results. Now, what's important to note as well when you are trying to deploy Amazon Kendra is they offer two different editions. So the first one being the developer edition, and the second one being your enterprise edition. And both give you the ability to create up to 5 indexes per account. But the enterprise edition gives you access to quite a bit more documents and sizes per document that can be extracted. And so if you're going to put something into production, you should definitely go with the enterprise edition. The benefit perhaps of the developer edition being that you get up to 750 hours of free use for development purposes, so that you can get your setup just right. Right, so let's have a look at Amazon Kendra. I'm going to do a quick live demo for you. So what I have here is I've opened Amazon Kendra. I've opened the Search Console within Amazon Kendra, within the service itself. I've already set up different data sources and an FAQ. So let's give it a couple of live questions. And so what I've done, I've preloaded Amazon Kendra here with about 30 or so Wikipedia articles. And it's on a topic of going to Mars. So you would recall quite recently, SpaceX sent some of their rockets to assist in taking astronauts to the International Space Station. And I guess eventually their efforts is to get humans to Mars. So let's take a couple of questions here. And maybe the first one being something like, let's see, who founded SpaceX? And the search there, like we saw in the example, Elon Musk. And it's quite certain, it brings it up as the first one. It found that in the article called The Colonization of Mars. And it's also, there's a couple of other interesting things that they rank here. So for instance, SpaceX, they bring up an article on Elon Musk on the Falcon 1, which you would all be related in some way to SpaceX and their efforts. So let's take a different example. Let's see, what is the SpaceX rocket called? And again, Amazon Kendra here gives us quite a conclusive answer, Falcon 1, which I guess was the first rocket developed by them. And gives you some supporting evidence. So in September 28th, SpaceX's Falcon 1 rocket, and then became one of the first rockets. If you kind of browse down here, you might see something like the Falcon 9 rocket, so maybe a different name. But in general, there was quite a bit of confidence that at least the word Falcon is associated with SpaceX's rockets. Now let's see, if we want to go to Mars, maybe it would be interesting to understand something, say, of the atmosphere of Mars. So let's ask a question. How much carbon dioxide is on Mars? And based on the Wikipedia articles that I've entered, it would say, well, there's about 96% carbon dioxide. Again, it gives you a bit of a snippet saying that Mars's atmosphere consists of carbon dioxide, argon, and nitrogen. Now, I'm sure most of you have heard before that there were a number of Mars rovers. So let's see, what is Opportunity? Opportunity and Spirit, of course, being two of the Mars rovers that went to explore Mars a few years back. And you can see the answer provided here, NASA's Mars rover. And maybe a final question. When did Opportunity stop operating? And based on the Wikipedia content, it can give me a very conclusive answer here, being the 10th of June, 2018. And what's quite interesting here, if you look at the sentence, is that Spirit and Opportunity, which landed on Mars in January 2004, operated until March 22, 2010 and June 10, 2018, respectively. And I think what's quite impressive here is the natural language models sitting behind this. Specifically, that in this case, it had 2 words or 2 different rovers. There were 2 dates specified, and based on the language structure there, it could correctly identify the specific date associated with opportunity. Now let's take a bit of a more descriptive question and also ask Amazon Kendra a question or 2 about that. So let's say something like, what do humans need to survive on Mars? And in this case, we don't expect a specific answer, but we can see here, based on the different articles, human survival on Mars would require living in artificial Mars habitats and complex life support systems, which might be the type of answer that we would be interested in. Now, suppose we want to just do sort of a keyword search. We've seen Donald Trump recently in the news when the SpaceX launched their rocket, taking American astronauts up to the space station. So we might be interested to see what is Donald Trump's effect on the missions into space. So let's say something like Donald Trump. And let's just say Mars. In this case, a keyword search. And based on the specific keywords that were provided, we can get a result here that in 2017, President Donald Trump promised to return humans to the moon and eventually to Mars. Which of course begs the question, what other presidents might have also had similar types of promises. So let's do something like Barack Obama. And we can see that in the same way as Donald Trump, in October 2016, President Barack Obama renewed the US policy to pursue the goal of sending humans to Mars in the 2030s. All right, let's do, as a final demonstration, perhaps something like a FAQ question. So let's say something like, who discovered Mars? And what Amazon Kendra did is to then also consult the different FAQs, and based on that, it's returning the results that Galileo Galilei made a telescopic observation of Mars in 1610. All right, and I think that about concludes it. I think we have 10 minutes or so to take a couple of questions. So let's see in the chat, maybe if there are some questions, or if you'd like to maybe ask a question, please just raise your hand, and then I'll give you some opportunity to ask a question or 2.